6 named reactions in 6 minutes. I will teach you my personal tricks to learn 6 named reactions in 6 minutes. The first reaction is Gutterman-Koch reaction. Well, the word Koch reminds me coach. If you remember this coach word and Gutterman-Koch reaction, you can write it in less than a minute. For example, this C stands for close structure like benzene. This CO stands for carbon monoxide. This S stands for aluminium chloride. This HC stands for hydrogen chloride. Now I take this benzene structure, I write it here. I take these 3 compounds and I write them here. Carbon monoxide, aluminium chloride and HCl. What about the product? Well, at the left hand side, there is benzene ring. So at the right hand side, there will be benzene ring. Secondly, chlorine and aluminium are not active elements in organic compounds. So I eliminate them. The remaining elements are COH. I write here COH. So everything just boomed. Thus in Gutterman-Koch reaction, we convert benzene to benzaldehyde. Now we will learn the second named reaction, ozonolysis of alkenes. Well, I take alkene. We know that ozone is O3. Secondly, this Z in ozonolysis reminds me zinc. This O reminds me H2O. I take zinc and H2O. I write them here. The trick is, ozone always attack on double bond. Let me repeat it. Ozone always attack on double bond. Thus I break this double bond. I place one oxygen on double bond of this carbon and one oxygen on double bond of this carbon. I take this compound. I write CH3 single bond CHO. I take this compound. I write CHOH. Thus in ozonolysis of alkenes, we convert alkenes to aldehydes like ethanol and methanol. Now consider this alkene. Pause the video and convert it to aldehyde. Well, through ozonolysis, we can easily convert it to aldehyde. I press O3. The other reactants are zinc and H2O. According to the trick, ozone always attack on double bond. I break this double bond. I place oxygen on this carbon and oxygen on this carbon. I get CH3CHO and CH3CHO. Therefore, using ozonolysis of alkenes, we can convert alkenes to aldehyde. Now we will learn 2 similar reactions, Wolff-Kishner reduction reaction and Clemenson's reduction reaction. First of all, we will learn Wolff-Kishner reaction. And the word Kishner, this K reminds me 2 things, ketone and KOH. This H reminds me hydrazone. This N reminds me that the formula of hydrazone is NH2NH2. Now I write ketone. I take potassium hydroxide and hydrazone. I write them here. What about the product? Well, Wolff-Kishner reaction is reduction reaction. By reduction, I mean reduce or decrease ketone. I remove this oxygen group from ketone. The remaining part is CH3CCH3. Now this carbon needs 2 hydrogen atoms. These 2 hydrogen atoms are provided by hydrazone. I get propane. Thus in Wolff-Kishner reduction reaction, we convert ketone to alkane. In Clemenson reaction, we convert aldehyde to alkane. Let me repeat it. In Clemenson reaction, we convert aldehyde to alkane. Here, remember this very important point. I do not say Clemenson reaction. I say Clemenson reaction. Now here, this Cl reminds me HCl. This Zn reminds me zinc amalgam. Now I write aldehyde. I take zinc amalgam and HCl. I write them here. We know that Clemmensen reaction is reduction reaction. By reduction, I mean reduce or decrease aldehyde. I remove this oxygen group. The remaining part is CH3CH. We know that this C needs two more hydrogen atoms, which are not present in the reactants. So I place H2 or hydrogen gas here. As a result, I get CH3CH3. Thus, in Clemmensen reaction, we convert aldehyde to alkane, while in Wolff-Kishner reaction, we convert ketone to aldehyde. Hence, noted down these two important reactions. Now we will learn the fifth reaction, Itard reaction. Well, and the word Itard, this T reminds me toluene, and this A reminds me aldehyde. I mean, and Itard reaction, we convert toluene to aldehyde. We know that in toluene, CH3 is bonded to benzene ring. Secondly, I take this benzene ring, I attach CHO to it, so it is benzaldehyde. But wait a minute, it is not that much simple. We need to put some sort of ingredients or reactants in between. Well, I teach this easy trick. I select two atoms from toluene and two atoms from benzaldehyde. This carbon reminds me CS2. This hydrogen reminds me H2O. This CO reminds me CrO2Cl2 or chromyl chloride. Thus, in Itard reaction, we convert toluene to benzaldehyde. And noted down this important reaction. Now, the sixth and the last reaction is Stephan reaction. Well, everything is there in the word Stephan. This T stands for nitrile. We know that nitrile is alkyl plus cyano group CN. I take this nitrile and I write it here. Secondly, this S stands for stannous chloride, HNCl2. This H stands for two things, HCl and H2O. I take these ingredients, I write them here. Now I say Stephan reaction is a reduction reaction. I mean, I cut this triple bond, I add HO to it. I get aldehyde RCHO. Thus in Stephan reaction, we convert nitrile to aldehyde.